In this session, we will control the ultrasonic sensor, and in the kit, you can see that there is an ultrasonic sensor. It is labeled as ultrasonic sensor, so there is an adapter available. Here you can see the labels: ground, echo, trigger, and VCC, and here. If we place it like this, it is labeled in the same order as ground, echo, trigger, and VCC. In this way, you should fit it into row 10 as much as possible on the inside. You can insert it like this and prepare it. Now, this side has 4 pins, and it is compatible with the 4 pins here. So, please use a 4-pin harness cable to connect and attach it. Next, please carefully, gently, and precisely insert the module. And this time we will also display the distance on the OLED display. Please connect the distance measured by the ultrasonic sensor in the following manner, as demonstrated here. Last time we simply opened the code. Please delete this, and then click on New File inside the lib folder to create a file named Adafruit HSAR04.py. And if you go to this link, you will simply find the Adafruit HCSR04 code file. Please copy this carefully from start to finish and then paste it right here. Save it. After that, I will try to input the code. To begin with, it is important to remove the ray notation from the sketch. This step is crucial as it ensures that the sketch is clear and free from any unnecessary markings that could potentially cause confusion later on. The ray notation, if left unchecked, might lead to misinterpretations or errors in subsequent steps, which is why its removal is a priority. Once the ray notation is erased, we can move on to the next task, which involves configuring the Sonacina Mimosa. This configuration process is quite detailed and requires careful attention to ensure everything is set up correctly. In this configuration, the pin designated for the current mode's TX position is actually the echo pin. This means that when you are setting up the device, you need to ensure that the echo pin is correctly connected to the TX position for the current mode. This connection is vital for the device to function as intended, as any misconnection could lead to malfunction or inaccurate data transmission. Similarly, the RX pin is used for the mode, which requires careful attention to ensure proper connectivity and functionality. Ensuring that the RX pin is correctly connected is just as important as the TX position, as it plays a crucial role in receiving data accurately. After setting up the pins, the next step is to adjust the height of the YL distance. This should be set to 40, which is a specific measurement that needs to be adhered to for optimal performance. The height setting is critical as it affects the overall operation and accuracy of the device. Additionally, the rounding distance should be configured to the first decimal place, which translates to 1 cm. This level of precision is necessary to ensure that the measurements are accurate and reliable. Precision in measurement is key to achieving the desired outcomes and ensuring the device operates within the expected parameters. Furthermore, it is beneficial to display this information on the console. By doing so, you can monitor the data in real time and make any necessary adjustments promptly. Real-time monitoring allows for immediate detection of any discrepancies or issues, enabling quick corrective actions. It is recommended to update the console display every 0.2 seconds. This frequency allows for a continuous flow of information, enabling you to keep track of any changes or anomalies that may occur during the process. By following these steps meticulously, you can ensure that the setup is both accurate and efficient, leading to successful operation and desired outcomes. The continuous update ensures that you are always informed of the current status, allowing for proactive management and decision-making. Let me just quickly check it once more, just to be sure. First of all, as expected, it clearly shows 43.2 in the console. But when I bring my hand close, it shows 11, 12.7, 4.5. Let's take a look at it directly. As you can see, it displays something like 43.2. When I place my hand like this, it measures 13 cm. If I place it like this, it measures 5 cm. And if I move it further away, it measures 22 cm. This is how you can measure distance with the ultrasonic sensor. In this session, we worked on controlling the ultrasonic sensor using CircuitPython. I will return with another topic next time.